Lesson 8.8, Quadratic Equations, Differences of Squares. Our essential question is, how do you factor a difference of squares? We have one new vocabulary today. It's also difference of squares. A difference of squares, the word difference, if I pick apart the meanings, the word difference means subtraction. And then when something is a square, that means a number times itself or a variable times itself. Something times itself makes a perfect square. So we are going to have two things that are perfect squares subtracted from each other because it's a difference. So a difference of squares means a squared minus b squared. And what you will see is that the factoring pattern we're working with is that our binomials would be a plus b and a minus b, or a minus b and a plus b. The order doesn't matter. On this next slide, I am going to remind you what happened when we FOILed and our binomials looked like that. So our first example is x minus 4 times x plus 4. If I multiply our first terms, x times x is x squared. Outside, x times positive 4 is positive 4x. Inside, negative 4x. And last, negative 16. What I want you to notice is that our two terms in the middle that are like terms are opposite each other, so they cancel out. So what we're left with is x squared minus 16. So you see the subtraction for the word difference, and x squared and 16 are perfect squares. So what we're working on today is reversing, not FOILing, but factoring. So we're working on starting with x squared minus 16 and recognizing that the two binomial factors that are equal to x squared minus 16 would be x minus 4 and x plus 4. Now, I have one more example that I'm going to FOIL just because there's a coefficient in front. So 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. 2 times 3x is positive 6x. And 2 times negative 2 is negative 4. So again, these middle terms cancel out. And I have 9x squared minus 4. So 9x squared is a perfect square. It's 3x times 3x. 4 is also a perfect square, 2 times 2, and it's a difference of squares because they're subtracted. If the sign between them was a plus, it would not be a difference of squares. You would not be able to factor it in this way. So this pattern only works when they're both perfect squares with subtraction. Okay, so hopefully you understand now that x squared is a perfect square. It's x times x. 25 is a perfect square. 5 times 5. 1 gets a plus, 1 gets a minus. You could FOIL this to check and make sure that it's correct. X squared minus 5x plus 5x minus 25. The middle terms cancel out, so we factored correctly. So the answer is x plus 5 times x minus 5. My next one, 16c squared is a perfect square for 4c, and 81 is a perfect square for 9. 1 plus, 1 minus. You can FOIL it to check. That's not required though. 16c squared minus 36c plus 36c minus 81. And the middle terms cancel. So 16c squared minus 81, we factored correctly. Okay, now on this next problem, there's a little problem here because when our exponent is a 3, it's not a perfect square, But if you notice that we've got a b in the other term that we could remove, we can just factor out that GCF. So removing the b from each term would leave 4b squared minus 121. So when you look at these problems today, you are always looking for a difference of squares. So you are looking to have a binomial, so two terms that are perfect, two terms that are each perfect squares with subtraction in between. So 4b to the third power is not a perfect square, but 4b squared is a perfect square because it would be 2b times 2b. And 121 is 11 times 11. So b on the outside that we factored out for the GCF, and then we'd be left with our binomials, 2b plus 11 and 2b minus 11. This next problem, the GCF is not just a variable, but it's also got a coefficient number. So 3 and 27 can both be divided by 3. So my GCF is 3y on this problem. That would leave me with y squared minus 9. 3y times y squared is 3y to the third power. 3y times 9 is 27y. Now I can factor it again because it's a difference of squares. Y times y is y squared. 3 times 3 is 9. 1 gets a plus, 1 gets a minus. Okay, a little bit more complicated again. These exponents are even numbers, they're 4s. So they are perfect squares. It's just that it's y squared times y squared that equals y to the fourth. And then 625z to the fourth would be 25z squared times 25z squared. 1 gets a plus and 1 gets a minus. Now this problem is more complex than the rest of them because this is a difference of squares and so is one of our binomial factors. So we actually have to factor this one again. Not the binomial that has the plus between the squares, just the one with the minus. Y squared is y times y, and 25z squared is 5z times 5z. So some of your problems today will require you to factor more than once. You just have to be careful and check to see if you have a difference of squares again. All right, this next one, I'm going to expect to have a difference of squares again. So let's see. 256 is a perfect square for 16. Don't feel bad if you need to use a calculator on these. And x to the fourth is a perfect square for x squared. So 1 plus 1 minus. The one with the plus I am done with because that is not a difference, that is a sum. The one with the minus though, 16 and x squared, are still perfect squares. So 4 times 4 is 16, x times x is x squared, 1 plus and 1 minus. That's factored completely. If you stop your factoring at the first step, you just haven't simplified it or factored it completely. It's kind of like reducing a fraction. Like if you reduce a fraction like 6/12 to 3/6, it's not simplified completely. Okay, factor completely again. On this one, I see x to the fifth is an odd number, so I'm going to have to factor out an x. I also recognize that even though 9 and 36 are perfect squares, I can factor out a common factor. So I'm going to factor out 9x, which would leave me x to the fourth minus 4. X to the fourth minus 4. Now I can factor that. It's a difference of squares. X squared times x squared is x to the fourth, and 2 times 2 is 4. This one does not factor again because 2 is not a perfect square. So this one I'm done factoring now. So even though I have a minus for difference and x squared is a perfect square, 2 is not. Okay. Next one, I can factor out just the 2, and that would leave me with y to the fourth minus 16. Those are perfect squares for y squared and 4. 1 plus, 1 minus. Then, the one with the plus is done. The one with the minus, though, they factor again. Y squared is y times y, and 4 is 2 times 2. 1 plus, 1 minus. Now I'm done factoring on that one. You should be able to write a summary now. Make sure that you answer the essential question and use complete sentences. And think about all of the steps, all of the different things that you need to consider to factor completely.